My name is Cam Vedbrat. I'm a lead program manager on the Windows graphics team at Microsoft. And on that team, I work on DirectX. I've been at Microsoft since 1998, and I've been working on graphics for about 7 years now. So today, I'm really excited to talk to you about how you can use DirectX in your metro-style applications. So when people think about DirectX, they often think about games, like Gears of War, like the awesome Samaritan demo we saw in the keynote yesterday. And that's natural, because DirectX is the most powerful graphics API in the world. And we want to make sure that that power is something that is in your hands and that you can use that to deliver the most amazing, fast, and fluid experiences in your metro-style applications. As a technology, DirectX has its roots in Windows 95, going back to the game SDK that first shipped for Windows 95. So it has over 15 years of really, really focused performance work that we've done with the IHV ecosystem to make sure that the API that we have really lets you squeeze out every last drop of performance from the GPU in your applications. So another reason that we think about DirectX in metro-style apps is the power that you get from a GPU is really ubiquitous at this point. And when we look at sort of the dollar cost that you pay for an amount of rendering horsepower, and how that has basically, how the amount of horsepower you get from the GPU for the dollar has been growing year over year, it's really quite amazing. We've seen almost a 3x growth every year in graphics horsepower from a GPU, and the price has really been pretty static. And in fact, on the low end, things have gotten even a bit cheaper. So what we have is GPUs that are really, really ubiquitous at this point. And in fact, every Windows 7 PC that you see out there and every PC that Windows 8 will ship on will have a really powerful GPU in it. And that power will be available for you to use in your applications. So we use the GPU because it's ubiquitous now. We can use it for more and more things. We used to use it for games. Now we use it for Internet Explorer. We talked about this a bunch at Mix earlier in this year. You saw it in the keynotes and even at PDC last year. IE9 has been a real amazing proof point for us in terms of our ability to use hardware acceleration in a broad set of scenarios. Another everyday scenario that we see DirectX being used in is Windows Live Messenger, Windows Live Photo Gallery, and in fact, all of the Windows Live Essentials applications use DirectX for rendering every single pixel. So we really have a strong base that's well tested and well proven for your metro-style applications. And this is why we were happy to give you DirectX as the foundation for all of the rendering that happens in a metro-style app. So HTML, if you're using HTML in your metro-style app, if you're using XAML, no matter what entry point you're using to program your app, you're always rendering with DirectX. And this foundation is something that you'll be able to build on in your applications as well. So the reason, so all metro-style applications are hardware accelerated, and that comes from us building the frameworks on top of DirectX. But there are times when you're going to want to use DirectX in your application firsthand. And those times will include when you want to optimize performance. There are places where you're going to want to squeeze out every last drop of rendering horsepower from the GPU to get the frame rate you need, to get the flexibility in the output you need. If you want to control how every pixel is rendered, if you really need fine-grained control over what's happening on the GPU, DirectX is the API you want. So within DirectX, we have really two classes of APIs. We have a set of APIs that are for rendering, and then another set of APIs that are for basically setting up resources that you would use for rendering later. So I'll talk about each of those. So we have Direct3D and Direct2D, which are our rendering APIs for 2D and 3D graphics. And then for resources, we have the Windows Imaging component, which is a component that enables you to encode and decode standards-based image file formats. We have Media Foundation for audio and video. And we have DirectWrite, which lets you crack open font files and set up text do text layout for things like typography in your applications, or even more simple text scenarios. So in Windows 8, all our rendering is based on D3D 11.1. And 11.1 has a handful of improvements in it that are really, really interesting and important for metro-style apps. So the first thing is we spent a lot of time optimizing for rendering and for rendering performance and for efficiency. So this means reducing state changes, making things go faster, and also making sure that we had a runtime that would work really, really well, not just on high-end systems, but also on smaller form factors like the ones that you see in the tablets that you have today and what we'll see with ARM devices as well. We added support for stereoscopic 3D graphics. So the high-end HD TVs that you can go out and buy with the 3D glasses that you wear, you can build games that actually take advantage of those and have experiences that come to life in 3D with D3D11. We made video playback work with Media Foundation, so you can have Media Foundation actually decode video for you to use in your 3D scenes, in your applications. And we made a ton of improvements in our software rasterization stack, so you can rely on software fallback always being there in every scenario. And there are generally not that many scenarios anymore with portable devices that you need to use this, but there are always going to be a set of them that come around. Things like remote desktop are an example of that. So there are some more talks about 3D itself, and there's a list at the end of the slides. I'm not going to dwell on the more talks here, but there are 3 talks about using Direct3D firsthand that are later on in the show you can see. So for Direct2D, the focus, again, has been on performance. You're going to hear me say that over and over again, performance. We improved the infrastructure for how 2D and 3D work together so that you can more seamlessly combine 2D and 3D graphics in your applications, and so that you can get much more efficiency when you do that in your rendering. We've added image processing effects to Direct2D, so there's a whole new API that we have that enables you to do pixel processing on rendered content on the GPU. And then we also have printing support in Direct2D now. So the same API that you use to express your visual content for display can be used to express that visual content for a print output scenario as well. So we have a couple talks about each of these. There's a talk later today about, or later in the week about optimizing 2D graphics performance. And then there's also a very good talk about the new image processing API that we have. So finally, in DirectWrite, we've also done a ton of performance work around making it so that the memory usage with DirectWrite is improved, and making it so that we spend less CPU time rendering text, because the work that we have to do there is because the text that you render on your screen, text is the most commonly rendered primitive in Windows, and that's something we can almost never make fast enough. So we spend a ton of time making text faster. There's better support for typography with improved kerning and justification. And then we added support for Unicode 6, for the Unicode 6 character set and the script processing rules that come with Unicode 6. So things like emoji characters are now supported with DWrite. So from here, I'm going to switch over to a demo, and I'm going to give you an example of a Metro-style application that's on the screen, that's built on top of DirectX. So let me go into Postcard. Oh, okay, I'm in Postcard. So what we have here is a simple photo postcard maker application. And what you'll see is it's, again, chromeless, like you expect a Metro-style application to be. The thing that's unique about this, though, is every pixel here is rendered using DirectX, using the DirectX API itself. So we're not using XAML or HTML or any UI framework here. We're just using DX to do our rendering. So I'll walk you through the app, and you can see, and I'll talk about what's kind of happening here. So the first thing we're going to do is we'll press add paper. So let's add some paper to our postcard. So what we have is, let me zoom in on this, actually, so you can see it a little more closely. So you can see, kind of as I zoom in, the edge of the postcard is very, sort of has this realistic construction paper kind of effect on it. And the way that that's accomplished is by drawing a bitmap with D2D, so it's a rectangle, and then we use our effects API to adjust the edges of it and to adjust the surface of it to give it that kind of realistic, bumpy construction paper surface. We can also add another sheet. We can change the shape of the construction paper by stamping little corners into our postcard. And what's happening there is we're actually using the D2D geometry API to combine the two geometries to find the intersection of the two geometries and then separate them out into separate individual shapes. So then we can delete the inside one, and now I've got these nice little fancy corners that I can put on my postcard. So let's add an image here. So here we're using the system file picker. This is the same file picker that you saw earlier that every MetroStyle application can get access to. And just as you'd expect, it has access to photo images that are made available by other MetroStyle applications. But we're just going to pick one from right here. So I'll start with it's a picture of my son here we can use. And so here he is on a boat on the ferry in Seattle. We can apply an effect to this image. So let's add an effect here. And what we have is a number of effects. I can go to grayscale. I can make it sepia. I can adjust the saturation. And one thing that you can see as I'm touching the display, the feedback on the image processing is very, very fast. We're able to do this in real time because all the image processing is happening in a way that's hardware accelerated on the GPU using the D2D Image Effects API. So let's add some text. So here we have some 3D text. I can move it around with my finger. The way the text is rendered is we're starting with DWrite to go get an outline for the text. As I switch between fonts, you can see there's some different effects the different fonts have. DWrite gives you access to all the advanced typographic features in a font. It gives you the ability to choose between stylistic sets. Basically, any OpenType feature that's in a font can be accessed by DWrite. But to get the 3D, we're doing a little bit more. So what we're doing is we're taking the text from the font, and we're asking DWrite to give us that text as an outline. And then we hand that outline to Direct2D, and then Direct2D actually tessellates that into a mesh. So we get triangles from D2D that came from the outlines of the text that came from DWrite. Then we extrude the triangles in our own application, and we hand that extruded mesh to D3D to go render. And that's how we get this really nice kind of 3D text effect. I can move it around with 2 fingers. I can pinch it and do all sorts of fun things with it. So let's maybe move it off of his face. So then the last thing I want to do is I want to sign the card. So I have my trusty stylus, and I can say, I'll put my name there, so Cam. And I can sign the card using ink. And the way the ink works is we're using the touch and pen APIs, the pointer APIs, to go get the strokes from the digitizer, and then those get handed to D2D as Beziers, which D2D goes and renders. And then finally, I can share that image out using the share charm, and I can share it to any MetroStyle app that supports taking an image for sharing. And so what you've seen here is a great MetroStyle app that's built. Oh, let me make the share contract go away too. What you've seen here is a great MetroStyle app that uses DirectX for all of its rendering, but it also allows it's also been built in a way that allows application developers to focus on what the key value is. So you're mixing 2D, 3D, text, all the elements, and the bulk of the code in the application is on that rendering system. The work to go talk to Socialite, the work to go share the image out, that's all handled by the contracts, and you can focus on your rendering code and making that really, really great, which is, in this case, the unique value of this application. So we have a comprehensive API that lets you do all of these things, and you can really work with all the different pieces together. And what this means is you can really build great MetroStyle apps with DirectX. You can use the frameworks, but all of the capabilities of MetroStyle apps that you saw that were new are available to you when you're writing code using DirectX, and you're also able to get to the low-level APIs for programming to the GPU itself together. So of course, let me go back to the VGA. Of course, DirectX can also still be used for building games, and so I'll just take a minute and show you one of the games that's installed on the tablet machines that you have. This is a game that was written by 3 of our interns over the summer. It's called Copper, and it's about a robot who really wants to get to a star. And so what I can do is I can just tap and move him around. I can control it. I can control the gear to kind of manage the 3D view and if I, hey, okay, the robot's not listening to me, and I can move the robot around. And just by using the tap events to send input to the app, I can actually move the robot around the screen, and then he celebrates once he finds the star. So it's a simple 3D game, but I think it gets the point across that all of the 3D graphics that you're used to for games, for rich entertainment titles, are also available for you to use in your Metro-style applications. So let's go back to slides.
Does it have to be C++, or can you do that in C#?
I'll answer this one question, and I'll ask folks to save their questions till the end. This is all through C++. The API itself is through C++. There are ways to get to C# through things like pinvoke. You can always do those sorts of things. But the API is designed for people to use with C++. So what you have here is really, what we have here is really DirectX being used to give you maximum control over the visual output. You would never express the robot as a XAML document or in HTML because we don't have primitives for those sorts of 3D things in XAML or HTML. And when you need that kind of control, we have DirectX for you to use that in your Metro-style apps. So let's talk about how you actually do it. So let me switch back to VS. So what I have here is a very simple Direct2D application, and I'll run it real quick so you can see what it does. So this is one of our Windows SDK samples. It draws some text on the screen, and you can do some things to the text. You can move it around and pinch it and zoom it, but I'm going to focus on just the basics of drawing for the moment. So let's get back to VS here. So when you get into your, so when we get into the code, the first thing that gets called when you start your app is we go into main. Main has two things in it. It has the creation of a view provider factory, and then of course the factory creates other things. And so we have this run method which comes out of core application run. And so core application run takes that factory, it creates a DirectX view provider, as you might imagine, and then it calls some methods on it internally, and I'll show you what those are. So there's three interesting things inside the view provider itself. There's the initialization, there's the load, and there's the run method. So let's go through each of those. So initialize is ultra simple. Initialize basically takes the core window and the core application view that were created by the system when your app started, and it hands them to it caches them locally within the object. So these objects get created basically as your application starts up. So then when we get to load, what happens is load is where the application basically figures out what it wants to show based on how it was activated. So you see this if statement where it says, oh, if entry point equals DirectX application. So if I go into our manifest, every manifest has entry points specified in them, and here's the one entry point that's in the manifest for this application. But you might have more because your applications can get started in different ways. If you get started by the search charm, or if you get or if your view gets created in the full view rather with another app snapped next to it, you might get a different way of creating the app, and so that's why we have multiple entry points here. So then once it's been loaded, then we call run. And so what run does is it creates a view object, and a view object is actually something that's almost an affectation of the samples that we have. We have this view class in our samples because it lets you sort of more cleanly separate the D3D and D2D rendering code from the core application logic that's going on. So all the application-specific stuff happens in the view in this sample. But you could just as easily have the same code be inside your view provider. And then within that, we call initialize and run again. let me. So inside initialize, this is where we set up all our events and event handling. So I'm going to show you inside initialize. Oh, I lost the line. How we handle a gesture event. So there's a thing called a gesture recognizer, which is an object that basically handles all of the touch input that occurs on the digitizer and then translates it into events that are specific to gestures that we think will be common in MetroStyle apps. So things like pinching and dragging all will show up as gestures. So in this case, we're just going to look at the tap gesture. So let me go to the next one. And so what I have here is, I'll select 2 lines. There we go. So what I'm doing is I'm adding an event handler to the gesture recognizer for the tapped event when you actually tap on the screen. And what I'm doing is I'm handing it the onTapped method of the view object. Oh, I get lost. So the other thing that happens when we initialize the renderer is we actually the other thing that happens when we initialize the view is we actually initialize the rendering code itself. So we create this D2D text animation object, which actually has all of the D3D and D2D rendering code in it. And so we create that object, and then we set that up with the DPI and the size of the window itself. And then from there, we run the view. So let me go into what run does. So what run does is basically it starts dispatching events to the application to go and handle. And one thing to note here is you want to make sure when you're using D3D that you pass process all if present. And what that does is it makes sure that the events are coming to you at the highest resolution possible, so you can have sort of the best performance in terms of touch responsiveness when you're processing the touch events. So the text animation class that we have actually inherits from a thing called DXBase, which is also something that's in our samples and it's in the VS templates. DXBase does a lot of kind of common resource creation stuff that every app will want to do. So we've saved you the work of that, but I'm going to walk you through what's in there just so that you have an understanding of it. So when you go to write your own applications, you can know how that works and you can have you can have control over that as you might need it. So within initialize, of course, we hand it the window size and the DPI again. And then there are three things that happen inside initialize. We create 3 types of resources. So device-independent resources are basically factories, but they're things that are going to be relatively constant throughout your app that don't have any kind of GPU affinity. Device resources themselves are your devices that have hardware affinity. They exist on the graphics card or in graphics memory, and they have to be managed that way. So, and then finally we have window size dependent resources, which are more specific to your view. And those things might have hardware affinity, but they also are dependent on the size of the window. So the surface that you render on is an example of that. So let's go into the device-specific resources first. So first thing we do is we create a D3D device, because all rendering that we have in Windows 8 and MetroStyle apps is built on top of D3D. And then from that D3D device, we hand the D3D device to the D2D factory, and that creates for us a D2D device. So we've gone from 3D to 2D. And then from the 2D device, we actually create a device context. So the device and the device context effectively together play the role of the D2D render target that we had in Windows 7. So once you've created the devices, then we go into size-dependent resources. Did I miss my factories? Okay, well, anyway. Up front in device-independent resources, there was some factory creation there, but I'll skip over that. You can see that in the sample later. So we're going to create the size-dependent resources. And so what we have here is we create a swap chain. So the method that's interesting here is create swap chain for immersive window. And this is the way you get the top-level window for your metro-style app and bind it to your D3D swap chain that you're actually rendering to. And then from the swap chain, we create a D2D bitmap, which is what D2D will go and render text onto. And then we set the target of the context to that D2D bitmap. So in Windows 7, we had a device context. And when you create a device context, that would create both the GPU surface that you're rendering on, as well as the context of the rendering, which was what created things like brushes and what actually did the drawing operations. In Windows 8, we've actually separated those out. So you can have a single context that has state, and then you can change the target of your rendering dynamically, which is why we have set target. And the reason we did that is it gives you better efficiency as you're going and rendering, especially if you want to go render to intermediate surfaces and then come back. And then finally, we have our render function, our render method. And within render is begin draw and end draw and all the things that all your drawing work happens here as well. So if you're familiar with how you would draw with D3D or D2D before, that's where all of this code goes. So let me switch back to the slides. Okay, slides are back up. So there's really four things to think about when you're using DirectX, or four things to keep in mind when you're using DirectX in your metro-style apps. So the first thing is app initialization has changed. So you used to have a def WinProc, you used to have window messages. All those things are gone now because we're not using user 32. We have these new core application, core window objects. So you set these up. Event handling is different as well now. So there's no message pump. Instead, we have a dispatcher, and you register for events, and then callback, and then your callbacks will be called for the events you register for. You can handle events for things like gestures, for the actual pointer events, which will translate between mouse and keyboard and touch. You can handle events for keyboard as well. And then our resource creation has been streamlined. So everything starts with a D3D device. And then from D3D, you go to D2D, you create a device and a device context. And each of these steps are there so that you can have total control over how everything gets created. And that's important as soon as you want to get into more advanced scenarios that might involve either multiple devices or more specific kinds of rendering techniques. And then finally, you do your rendering. And the rendering logic is actually largely unchanged. There are some new features that I talked about earlier for things like effects and for printing. And there are new features in D3D as well. But the core of how you render with DirectX is intact, and it's preserved so that you can have all the same power and all the same control that you're used to having from DirectX in your metro-style apps. So what do we have? We have a new foundation for graphics. You heard yesterday that GDI is gone, and it's true. There's no GDI, there's no GDI+. DirectX is the way you render in metro-style applications. And this foundation is something that we've built all of our rendering technologies on top of. The way that you get to UI controls through XAML and HTML are all built on top of DirectX, and the way you build more graphic-specific content in your metro-style apps is also using DirectX itself. Using DirectX gives you maximum control. You get control over how execution happens on the GPU. You get control over performance. You get control over allocations and memory usage. You get control over rendered output. So you can really manage every pixel exactly how you want it. Manage so that every pixel shows up exactly how you want it to be. And the great thing about that is you really can build anything with DirectX in your metro-style app. And this is really kind of an empowering technology in that it takes away every limitation that there could be. You can draw anything you want on the screen using DirectX. Obviously, you should, for user interface scenarios, stick to the look and feel that kind of Jensen outlined yesterday. But when you get into things like games and when you get into kind of more immersive scenarios, you will have total control using DirectX. So to learn more, There are a whole raft of sessions that we have at the event, and they're listed here. We have a set of talks about how to build games using DirectX and Metro-style as Metro-style applications. We have a set of talks about how to do rendering, and then there's also some interesting talks about the tools that we have for using DirectX in your apps. My further reading slide is gone. So there's also a number of samples in the SDK that you can go and check out, and they're available for you as well. And there's a forum on the Dev Center where you can look at where you can give us questions if you have questions about how to build apps using DirectX in your Metro-style apps. And I guess that's it for today. So I have a little bit of time left. I can take a handful of questions. And thank you very much. Maybe there's some microphones here if you want to kind of queue up, and then we can just go one by one. If you wouldn't mind just introducing yourself before you ask the question, then I know who's asking. So we'll start over here.
Oh, okay.
Yeah.
My name is James Ashley. So I was just curious. It seems like a lot of the game discussions over this week revolve around DirectX. Does XNA have a place on the Windows 8 platform?
So we focused on DirectX as our core technology for building games, and we wanted to make sure developers have that base for people to go build on. So the XNA framework itself is not there.
Okay.
Andrew Harding from B-Square Corporation.
Okay.
We do a lot of embedded work. We're wondering, you mentioned that this will work on ARM as well. We're wondering what your technology is to bridge DirectX and OpenGL.
I'm sorry.
How are you bridging from DirectX to OpenGL that most of the ARM chips support?
So the OpenGL support that we've had in Windows is always there, and it's there for use on the desktop.
But what about the ARM tablets?
So Metro-style apps can use DirectX, and we haven't made any announcements about OpenGL in any other scenarios.
So you mentioned ARM. Will all this code will work on ARM?
So all the DirectX usage will work on ARM, yes.
Okay, but you're not saying anything about how you're working underneath to get to the hardware acceleration on the ARM chips?
So I'm not sure I follow your question.
Well, so like the Imagination Technology cores are very different than the GPUs that are on x86 chips.
I see. So we're working with the ARM vendors the same way we work with other silicon vendors to make sure that the DX runtime works well on that hardware. And if you have a sort of a more very scenario-specific question, you can talk to actually Amit and some of the other guys from the team are in the back. We can talk to you about it at the booth. But the D3D API is there, and it works just as it would on desktop.
All right, cool. Thank you.
Yeah.
Hi, it's Chris Coble. Several months ago, I spent a lot of time comparing D2D performance against WPF's high-performance rendering. Okay, so my company renders maybe in a single window upwards of 100,000 to 120,000 individual graphics, right? Which is a lot. D2D was probably twice as slow as WPF. So these are very different technologies, right? One is immediate mode, non-managed for Direct2D. WPF is managed with retained mode. Do we have I'm getting to just giving you context. Do we have a story, or does Microsoft have a story for a high-performance rendering with a non-immediate mode API, which would be akin to a transition path from WPF?
So there was a lot in that question. So first thing I'll say is D2D is very fast. It's much faster in Windows 8. And we've done a lot of work to make the API faster, to make primitive rendering faster. There's a session about that tomorrow that Megha Jain is presenting, and I suggest you go there to learn more about that. She also has a bunch of great techniques to go and look at to learn how to make your D2D code really hum. In terms of having a retained mode system, there is the XAML framework. You can use XAML to do some amount of 2D drawing. SVG is there for HTML apps, and those are the ways you would do retained mode.
So in this new subsystem, we're talking about WinRT with the XAML sitting on top, right? are there primitives for drawing? We have 2D geometries, all the fills that come along with those, things you expect from like the direct 2D geometry drawing supports all the common stuff you would think of, right?
They're not the same API. Like XAML has a set of things that are there that follow from its roots from WPF and from Silverlight, and then SVG is a well-defined standard, and so that's what's there.
Sure. Okay. Thank you.
My name is Bill Best, and I'm from Jefferson, and I have a question, I guess, about the collections and what type of things, because now there's no more MFC I can see, and C# gives you a rich collections, objects, and things. Do you guys heavily rely on like STL and possibly different?
So there are a number of talks about what there is in C++ that are later on in the show, and I suggest you go to one of those and hear more about it there.
My name is Julian. I want to get back to XNA a little bit. I understand the previous person that asked that, you said that XNA wasn't immediately supported, but would you be able to take a Metro UI app and, download a Metro UI project in C#, download XNA 4 and still be able to use it, or would it just, not compile, not work? I mean, I was wondering if you could speak a little bit more to that.
The bits for XNA aren't really there. So that's XNA supported for desktop games, but for building games on top of for building Metro style games, you should use D3D. And we've brought some of the functionality that XNA has into the APIs for Metro style apps. And there's a couple talks about how to do things like audio and input in Metro style apps that you can go look at. But the sort of drop a project in, that's not something you can do.
And just to follow up on that, I guess, since Windows Phone 7, XNA is supported there, is there going to be any future planned support for XNA? Perhaps, like V2 or something like that?
Yeah, we're not going to talk about what's happening in the future. We've got a bunch of stuff that we're doing now, and we're excited for you guys to use that.
My name is Joe Strumman. I have a two-part question. Can XAML-based UI live in the same application with DirectX-based UI? And then, if so, can they live in the same actual screen real estate?
In the developer preview bits that you have today, that's not something that's supported.
Okay.
My question is...
I can't hear you at all. I'm sorry.
Testing? Yeah.
Yeah.
Okay. So my question is, will Windows tablets require D3D 11.1 in hardware? Is that the assumption?
The question was, will Windows tablets require D3D 11.1? D3D supports a broad set of hardware going back to, well, it's a very broad set of hardware, DX9, DX10, and so forth. That continues to be the case. So.
Okay.
There's a couple more, and then we'll wrap up.
I'm Dror, also from AMD. What happens to full screen apps and Metro, and how does it play together with all the...
So the desktop API, the set of APIs for desktop apps continues to be as it is. We have a strong commitment to compatibility there, and we're maintaining that commitment. Metro style apps are obviously different. They happen to take up the whole screen. So in that sense, they are also full screen apps.
But what would happen if I declare a full screen app, which is basically the display becomes exclusive to that app? What happens to Metro? And
so this is something we should probably follow up on in the booth afterwards.
okay.
So we have some people who are more familiar with D3D itself. They can talk about that.
Hello, I'm Thomas J from Samsung Silicon. Actually, I'd like to ask about the kernel interface. In the case of Windows 8 Slate, what kind of DDI is being used in kernel side?
I'm sorry, I couldn't hear you.
In the case of Windows 8 Slate, what kind of DDI interface is being used in the kernel side?
What kind of DDI interfaces?
DX9 or DX11?
So, as I said before, we support a broad range of hardware. There's some talks about the driver model and WDDM that are later on in the show, and I think those questions would be better directed there.
Okay, and one more question.
Yeah.
Is there any architectural difference between ARM-based DirectX application and x86-based DirectX application?
Your code should be structured largely the same way. I mean, certainly some GPUs are more powerful than others, and internally they might render differently. But the API, there's one API for getting at hardware accelerated graphics in MetroStyle, and we expect you to be able to write an app and have it run pretty ubiquitously. There's a talk later on this week about how you scale your rendering content from across a broad set of devices, and there's more information to hear about there.
So can I understand this way? I mean, same API will be used for ARM and x86 based.
Yes, it's one API.
Oh, thank you.
Oh. Yes.
Hello, my name is Alexis Glass from Digion. You discussed at the beginning, I think briefly, about how Media Foundation, you can render video to a DirectX surface.
Yes.
I wanted to confirm whether there was output protection on this, if you're in a protected media path or...
Output protection. I don't know the answer to that question, but if you come to our booth, somebody there will.
Okay, thank you.
Hi, my name is John. I work with SAS Institute. All those good performance improvements you mentioned at the beginning about direct write and things, will those show up for desktop apps as well?
Yes, they will. So the focus today was, and the focus of the event is on MetroStyle apps, but it's not a separate DirectX.
Okay.
It's the Direct2D, the Direct Write, all the pieces that are on top of it are there in desktop apps as well. And in fact, the Internet Explorer that you saw demoed yesterday, the immersive one, or the MetroStyle Internet Explorer uses Direct2D and Direct Write for all of its layout. But we also showed the desktop Internet Explorer, and that uses the same rendering engine, and it uses DirectX the same way.
The splits of the, what did you say, the device context, where there's a little more granularity now to control it?
That's all there.
A little bit of an API change, but that would be exposed in both places?
Yeah, so the API that was there in Windows 7 and Windows Vista, we preserve compatibility with that, and then we also have the new API constructs are there as well.
Thanks.
So this will be the last question.
My name is Hélène Danlos from OC. In one slide, you mentioned D2D and printing.
Yes.
Can you elaborate on that?
Sure. Can you ask a more specific question?
There was just one word saying D2D supports printing or something is done.
Yes. So so D2D has support for printing now. So I talked about set target in the code walkthrough and the separation of sort of the device context, or how render targets became a device context and a target. And that was actually part of the motivation for that was so that we could enable scenarios like printing. There's a new construct in the API called a command list, and you can pass the command list to set target. And what command list does is it collects up your rendering instructions, and then there's another API object you can hand the command list to, which will basically send that content to the printer. So it's one rendering API. All the primitive drawing and resource creation is all the same. You set the target to a command list, and then that's how you go out to the printer. Thanks, everyone.